Hey everyone, my name's Joel. I'm the director of NAmTrans and I also work in the Economic Development Department of the North Country Chamber of Commerce. As part of our ongoing video series of how plane parts are built right here in the North Country, today we're on the job at Norsk Titanium. If you're from the North Country, chances are you've heard the name Norsk before. But today, I'm going to show you how Norsk is truly innovating the future of metal manufacturing. But to do so, first, we have to go back in time. In the past, upstate New York was home to metal foundries. At these foundries, metal was melted into a liquid, poured into molds, and then, once cooled, was machined into the desired shape to create the final product. This process, however, is inefficient, requiring lots of material, creating lots of waste, and taking a long time to create the desired product. Today, many of these foundries have since closed, but Norsk is bringing this industry back to the state with a modern twist. By using a new innovative process called additive manufacturing, Norsk Titanium is supplying highly engineered components to aerospace, defense, and industrial companies using less material, less energy, and in a much faster manner. Since 2020, this Norwegian company has occupied the 80,000 square foot facility behind me, where they are applying this proprietary technology at an industrial scale. Located at the former Clinton County Airport, the building behind me is the result of a groundbreaking partnership between Norsk and the state of New York. This one-of-a-kind facility is capable of producing over 700 tons of material per year. Norsk Titanium plans to employ many engineers over the next few months, machine operators, and support staff as well. Through these doors, there is a quiet, clean factory floor where Norsk technicians are transforming titanium wire into highly precision parts for their customers. They have a lot of work for me to do today, so let's head inside. So now we're inside the facility that you just saw outside. The whole process here at Norsk begins just like any other manufacturing process, with a design or a diagram or a model. That process starts here. Let's figure out what that's all about. Hi, you're Joe, right?
Yes, sir.
Joe, nice to meet you. My name's Joel.
Nice to meet you, Joe.
So Joe, you're going to show us a little bit about how the technicians here at Norsk know what to build. Is that correct?
That's correct. So typically what we see when a customer wants us to build a part for them, they'll send us their finished shape currently, whether it be on an airplane or any application that they're looking to either replace a traditional forging with or a billet shape or anything like that.
Okay, so we were just talking about forging earlier. So forging would be a process by which they pour the metal, it cools, and then they shape it down into what they want. You guys are building it from the ground up.
Yep, a traditional way of doing it would be subtractive. This is a completely new approach with additive. So this is one of their finished shapes that they've sent us. And from there, it's up to me to design the part around their shape and optimizing the layout. So what we traditionally do, and you'll see when you go out on the floor, is we print on a substrate, which is basically just a big rectangle of titanium.
So this is the substrate right here?
So, so my first step in designing the parts here is to figure out the best layout for the substrate itself.
Okay.
And once we have that, then we move to actually our RPD material, which will be representative of what we'll actually be printing.
All right, excellent. Well, Joe, I'm happy to have you here in the North Country, and it was a pleasure talking to you. So after this is finished, where do we head to next? What's usually the next step in the process?
So after we print this, we would send it out for, depending on the inspection type, we would have it sonic machined. Okay. And then it would go to inspection to make sure the material is good.
Okay, gotcha. All right, well, let's go check out that next process then. Joe, it was a pleasure talking to you.
Nice talking to you as well.
All right, so we just finished up with Joe Gerard and he showed us how a model is designed here. And the next step in the process is picking the substrate. So we've moved to the back of the facility, from the front of the shop in the offices to the very back of the facility. And to help me do that, I have Kristen and Megan here, and they're gonna talk to me a little bit more about how that substrate is picked, as well as how they manage the shop floor and what system they use. So let's go meet them. Hey guys. Hey Kristen. Nice to meet you. Megan, nice to meet you.
Nice to meet you.
All right, so Kristen, what happens next? After the model's been produced, what's the next step in the process here at Norsk?
So before production can start, they have to reference their internal work instructions to find out what their specifications are for material.
Okay.
So
you want to take us over?
Over to the computer.
Okay. This process, that substrate, is using less material than if you used it in a typical forging way. So if you were forging something, you would take like a big block of titanium, like a solid block, and then you'd kind of like, you know, machine it down into what you were making. But in this process, you guys are just using a tiny little substrate plate.
This gets closer to the shape that its final shape.
Okay.
So we use much less substrate than what would be done if it was forged.
Okay, gotcha. All right, perfect. So once you know kind of what the specs are for material and everything, then how do you go and pick it? And where is the substrate usually? Where do you guys find that substrate?
In the warehouse.
In the warehouse,
yeah.
okay. So should we go pick it next if we know where to find it?
Yeah.
Okay, perfect. All right, let's walk on over. So I think we're at the warehouse now. This is where the racking is and the substrates are. So how do we know which one is the one that we're picking?
So I printed that first page that we were just looking at.
So the work order.
Yep, the
okay.
work order, and there are numbers that would match.
Right on the
substrate. Yep.
Okay. Okay, so then where do we take it back now?
Yep.
Okay.
Take it back to the engraver.
Okay. So we pick the substrate from the racking. So now we engrave it. Is that right? Okay. Okay. Cool. Can I engrave?
Yeah. Sure.
Excellent. So what do I need to do to engrave?
So first, make sure that you're wearing gloves
Okay.
and hearing protection.
Okay. So gloves and hearing protection. Safety first. It's going to be a long day if I can't get the gloves on.
This is your engraver.
Oh boy.
So on here, you can see that your engraving is going to be up in the top right-hand corner.
Okay, excellent. So that shows you what Joe creates, shows you where to engrave on the substrate. Okay. Okay, so are we straight? Looks good? Okay, oh boy, I'm gonna pull the trigger. All right, let's go. 3, 2, 1. Oh my God, that's amazing. Oh, and did you see this on the job with Joel? That's pretty cool. All right, I love that. All right, so we've engraved our substrate, and now the next step in the process is actually going to be clamping it down on the jig. So we talked about the jig and the substrate and the clamping and why that's important with Joe at the beginning of the video. So I'm still here with Megan, and Megan's going to show us how to clamp that substrate down on the jig. So Megan, what is the process? How do we do this?
So first you pull up your clamping plan.
Okay.
And we've got that displayed there. And then you take your substrate that we just got done engraving.
Okay.
And you want to put it on the jig the way that it's oriented on the clamping plan. Your engraving would go in the top right-hand corner.
Okay. And then line them all up. Well, you're faster than I am. You're a pro at this. Okay. And so why is this process important again? Why clamping it in? It's to make sure that the substrate isn't moving while it's being printed?
Yes, make sure it's not moving and make sure it's in the right location for the program.
So do we have to tighten these down now?
Not yet.
Okay.
First, we have to measure. We just make the adjustments as we go here. And then we have a torque wrench.
Okay.
I've
used these before,
You have?
believe it or not. Yes, at other work locations. So hopefully I can put my skills to the test here.
Okay, perfect. Did you want to try?
Yeah, could I try that one?
two?
Oh,
Yeah,
here, should
sure.
I come on this side?
Yeah, you can.
Okay.
There you go.
Okay, so remind me one more time. So I'm putting it here.
Yep.
And then,
There you go.
okay. And then as soon as it starts to resist a little.
Yep.
Okay, perfect. Is
you
that
go.
one all right?
Yep.
Okay. Oh my God, look at that. That's awesome.
After we do that, we will load it right into the machine.
Awesome. All right, great. Well, thank you so much for your help.
No problem.
So now we have the substrate clamped onto the jig. So now we're gonna roll it over. We're gonna talk to Nick and we're gonna get it into one of the machines for printing. Let's get started. All right. So Nick, Joel, nice to meet you.
Joel, nice to meet you.
Nice to meet you. So Nick, we're gonna load this into the machine now. Is that the next step?
We're gonna load in the machine and that's where all the magic happens.
Okay. So what's the first step in that process?
We're gonna get it ready. We're gonna put it into the inload chamber over here.
Okay.
It gets a little tricky to steer, so if you wanna put one hand here and one hand here, and you'll be able to guide it right in. Good right there.
Okay, perfect.
And we're gonna jack it up. And just jack it up to about here.
Okay, keep going.
Kind of roughly there. We're gonna adjust it.
Okay,
All right, we'll lock it. Now we're gonna head over to the MES system. Have a seat.
perfect.
So now we're just checking our wire, making sure it matches up.
Okay. And we haven't spoken much, Nick, about the wire yet. So the wire is what you guys are, in effect, it's titanium wire.
Yep,
And you guys are superheating it, you're melting it.
yep.
And that's what's gonna print on top of that substrate. and cool into the part that you guys need, right? I mean,
Yep.
that's what is happening. Okay. All right.
Basically just building the outer preform of it.
Yep.
And then eventually it'll get machined down in the further process down the line.
So I'm sure most folks at home have probably seen like a 3D printer at their school or maybe at like a makerspace where they use plastic, right? So they take plastic wire and they melt that plastic and 3D print into something like a toy or a model, maybe for Dungeons and Dragons or something. This is similar to that process. They're just using titanium wire instead of plastic. And it's pretty cool. I'm excited.
Okay, now we're getting ready to push the machine data.
Okay.
It's gonna head over to the HMI, which
Okay.
is basically the printer.
Okay.
So we'll move over here, Joel.
Okay.
So now we're gonna go into the loading chamber,
Okay.
and you can go ahead and hit copy MES data.
Right here?
Yep.
Okay. Oh, and it auto-populates. Got it.
And then we'll close that out, and
Okay.
then you can go ahead and hit load palette.
Oh, that's pretty cool. That's really cool.
So now we'll come over here and we'll
Okay.
load it into the chamber. So it looks like we're gonna do pretty well. Now you can hit over there. It should be loading or jog in.
Oh, jog in right here?
Yep.
Okay.
And then it'll pull it in itself. And then now we're gonna hit acknowledge.
Acknowledge. Got it.
And that will shut the door.
Oh, that's really cool.
Now we're gonna upload our program.
Okay.
Okay, now we're gonna run back over to the HMI.
Okay.
We're gonna locate our substrate zeroing.
Okay.
It's gonna check for the height. We're gonna make sure everything's good.
So Nick, what do we do next?
We're gonna go ahead and hit RPD program.
Run RPD program. So how long would a print like this part take total? Once it's in there printing?
This one is a 2-hour print.
2 hours?
Yep.
Okay, really? And do you guys usually monitor the whole time on the
Yep.
cameras? Yeah?
Yep.
So our product's finished printing, so the part's in there.
Yep.
And now we're gonna just unload the pallet out the exit. Okay,
Yep.
got it. All right, so deliver pallet.
And it's on its way out.
Okay. Follow you over here.
So we're pretty much gonna do the same thing as we did putting in. We're gonna jog it out.
Okay, jog it out, got it. Oh my God, that's so cool. Okay, so we went from a substrate that had 0 on it to this printed final part. And this is again, what is this part called, Nick? An
Aft galley.
Aft galley. Oh, that's so cool.
And now we're gonna unjig.
Okay. So this is the part that just came out of the machine. So we unloaded this. Now what we're gonna do is we're gonna take it over to the scanning department. We're actually gonna scan this part to make sure that the geometrics of it, like the physical characteristics, the size, the height, the width of the metal is actually what the customer needs. There are minimum requirements, right? So when they machine down this part into the part that's needed, the metal can't be too thin. So we're gonna go to make sure that this is what is needed. Follow me. All right, so we finished the part, it came out of the printer, we rolled it across the facility, and now we're at a scanning department. So what we're gonna be doing here is I'm gonna be working with Rudy, and I'll introduce you to Rudy in just a second. Rudy's gonna be helping me scan the part to make sure that the geometric shape of the part is good enough for the final product. So a lot of times with these parts, there's still some machining that's involved. They're gonna need to make sure that that part is what their customer needs. They're gonna be comparing it to the very first model that we saw all the way back when Joe produced that model to make sure that they can get the part that the customer needs. So Rudy, nice to meet you.
Nice to meet you.
Yeah. So how does this process start? How do we scan and make sure that the part is what we need?
All right, so we're going to be using the Creaform Handy Scan right here.
Okay.
This is going to use a laser to produce a 3D image of the actual part.
Okay.
The first step we have over here is taking the part that came off the RPD process,
Okay.
and we're going to apply a coating. The laser does not reflect well off shiny surfaces. So
we want it to be shiny, but when we get to scanning, we don't want it to be shiny.
exactly.
Got
So when
it.
we get the scanning, we can't
Got it.
have shiny. So we're going to reproduce this right here.
Okay, perfect. So we're looking to make that. Got
Yep.
it. And what am I spraying onto this?
So what we're spraying onto this is a 50-50 mixture of Windex and tempera paint. They're just a water washable paint.
Oh, interesting.
So non-toxic.
Okay, great. So I don't need like a respirator, nothing like
Nope,
that?
we're just going to keep a nice, good distance, arm's length away,
Okay.
and about yay far from the part to paint it up.
Perfect. All right. Can I try my hand at it?
We'll turn the air on here.
Perfect.
And done.
Perfect. Look at that. That was pretty cool.
All right.
All right, sweet.
So there's a name tag on the part, and we use the same name tag location that they use in the clamping plan for using this jig right here.
Okay.
So in this situation, you're going to rotate it 180 degrees and lay it right down against these locating pins. So we're going to base it here.
Got it. Oh,
You got
gotcha.
it.
Okay, perfect.
Making sure to keep complete contact to points A, B, and C right there.
Got it. Okay, perfect.
So now the scanner works by using these dots.
Okay.
And we're going to place these dots on the surface of the part.
So the scanner bounces off from these. It's detecting these.
So those are location. It uses those to locate the area, and it'll just measure the part using those as a general location.
Gotcha.
It knows where all these dots are here and here. So this is establishing the X, Y, and Z plane for the part when it gets loaded into a computer program later to do the three-dimensional measuring.
Gotcha. Okay. I think that's pretty good. Okay.
So we'll go ahead and start the scan.
Okay.
Don't point it at your eyes. And when we start, we're gonna point it at this.
Okay.
And then we're gonna come up this side. We just wanna kind of see some dots that already exist.
Okay.
And then bring the image into life.
Follow them around.
Go ahead and bring it on up that pillar.
Up the line.
And as you can see, we're starting to populate data.
Oh, that's really cool.
You'll just see the parts start to fill in. Perfect.
How's that look for the bottom? Pretty good?
Go ahead and press and hold that button. It'll load the image into the computer. So, very good job. Look at that.
Thank you. For the first time, is it okay?
It's doing pretty good.
Okay. Thank you for your help.
You're welcome. But what we want is to be able to establish whether or not we meet the minimum material requirements.
Okay.
Which we will do now.
Okay, perfect.
And this is one of the CAD models you might have seen earlier.
Yep.
So here's the CAD model.
Okay.
And here we've overlaid the scan.
So it's just putting one on top of the other. The CAD model, the thing that we wanted to produce, and we're putting the scan that we just did on the actual part over it to determine what the differences are. Okay.
So I'm going to take and I'm going to move the CAD model.
Oh.
And now we're within minimum acceptance requirements.
Okay.
We got a good part.
What are minimum acceptance requirements? 0.2?
More than 0.
More than 0. Okay. Excellent. So would this part pass?
That's it. This part passes.
Excellent. Oh my goodness, that was so much fun. Thanks, Rudy. I really appreciate it.
Yeah, you did a great job.
Thank you. Am I hired?
You're hired. Well, you got to talk to him first.
All right, I'll talk to him after. Thanks, Rudy. So now that we've scanned the part, the last step in the process is the non-destructive testing, or NDT. And what we're doing in this process is we tested the size and the shape of the metal before to make sure that it could be machined down. And the final step in the process is making sure that the actual printed material doesn't have any defects or deformities in it. So I'm going to work with Elijah to make sure that that metal is exactly what's needed for the part. Hey, Elijah, how's it going?
Hey, Joel.
All right, so NDT, tell me all about it. What are we doing here?
So NDT, we are going to be sending some sound waves through our part to make sure that we don't have any defects.
Okay.
So what we're going to do right now is we're going to look at our reference so we know what our bad material would look like, and then we're going to look at what a real piece would actually look like.
Okay.
We've got a couple of holes in here that we drilled on purpose, so it simulates what a bad part would look like.
Okay.
But we're going to look at a real one in a second.
Okay, perfect.
So what we're going to do is you're going to take this probe here, and you're going to hold it sideways, kind of on the material like this.
Okay. Oh, I see. Okay.
What you're seeing is the sound, and you're seeing it go in from this top surface all the way to the back.
So why is this process so important for the part?
So in the aerospace industry, every part has to go through an inspection.
Okay.
We can do all of the cool stuff that we do in our building.
Yep.
Without this step in the process, our parts don't go on planes.
Okay.
End of story.
Yeah, because if there's a defect in the metal and this
There's a
fails.
defect, that could be a critical failure.
Okay.
And you're gonna see that there are no defects in there.
This is what it's doing is it's laying melted wire on top of itself over and over again, and there's no defects in it.
Completely fused.
That's completely fused. That's incredible. It's as if you had a solid piece of metal that you machined out from the beginning.
And that's our whole point, is we're able to make a solid piece of metal from the beginning, but we just build it up. We don't take it away.
You don't take it away. And you save material, you save time, you save energy, you save a lot of stuff in the
Exactly.
process. There's a lot less waste.
Exactly.
That's incredible. If you found a part that doesn't have any defects, say like we had this part, we did a full scan on it, then it goes out for some additional machining.
I give this the final check mark.
Yep.
And then this would go out to our final machining.
Yep.
Where we would get our finished part.
Wow. And that's the full process.
And that's the full process.
Elijah, thanks so much. This has been an absolute pleasure.
Thanks, Joel. Pleasure having you.
Thanks. We hope that you enjoyed your sneak peek behind the scenes today at Norsk Titanium. We had a great day. We started with a CAD file from the customer and brought the titanium wire all the way through the finished product that will pretty soon be flying on an airplane. If you're interested in working at Norsk Titanium, check out their website, norsktitanium.com. Thanks so much for joining us on this episode of On the Job with Joel. We'll see you next time.